Today, on Pat's Car Garage, let me explain part 2 of the electric fan conversion, which is how to wire up the fan controller to the air conditioning system. So here I have a new receiver dryer for the air conditioning system. So what you need to do is you essentially need a pressure switch that tells the fan controller when to turn on. And I found these universal pressure switches that control the compressor on-off through either the pressure being too high or too low, but they also have these fan connections. So when you hit, I think about 17 bar, these blue wires connect together. So I still need to wire up a plug for that. I did wire up a Deutsch connector for the compressor side of things already. So actually, if you're wondering how to hook this up, so the receiver dryer has a total of 5 ports. Of course, there's I forget which one's the in and out, but there's the 2 ins and outs. And then you have the air conditioning pressure switch, or the pressure sensor actually. So this is sent back to the climate control unit as a proper sensor signal. And I thought a long time of how I could tap into this or get the data off of it, off the serial interface or something. Too complicated. There's the refrigerant temperature sensor. So this, the combination of the temperature sensor plus the pressure sensor allows the system to know how much refrigerant is in the system and shut the compressor off if it's too low. And then normally over here you have a pressure relief valve. Now, as you can tell, I've got rid of the pressure relief valve and instead fitted this other switch. Now, to kind of get some of that safety back that the pressure relief valve would give me, I will hook up the compressor to this. So in case any other sensor fails, this is kind of a fallback and we'll shut the compressor off in the event of overpressure. And then, like I said, the blue wires go to the fan controller. So I'll power the fan. I'll show a wiring diagram on screen, but I'll wire the fan to the fan controller. I'll run one leg of this wire from the input on the controller into the switch, and then the output will actually go back into the fan controller's own input for the sensor signal. It's all 12 volt, by the way. So, and then the compressor is on the black wires. So that's pretty straightforward. It should work. Just gotta stick this in, do the rest of the work, and test it out.
Here's the best artistry I could muster up to draw a wiring diagram. A couple of things to note here. The fan controller power supply comes from the old auxiliary fan fuse. I will be removing the auxiliary fans and have everything controlled by the main fan, so that's a free way of gaining a fused circuit. I will also be reusing the auxiliary fan ground as the main fan ground. AC clutch goes to the black wires on the new pressure switch. There is a connector there to allow replacing the pressure switch should the need arise. The AC fan header of the DCC controller is wired to the blue wires on the pressure switch, and fused power is directly supplied off the controller input. This way, as soon as AC high side pressure reaches 17 bar, the DCC controller commands a minimum 50% duty cycle on the main fan. I've added a 470 microfarad 35 volt electrolytic capacitor between the DCC controller input and ground to compensate for line inductance from the long power run from the battery, which is in the trunk of course. All the other connections are self-explanatory. If your fan spins the wrong way, flip the output and ground wires to reverse the direction of the fan. That's basically it. If you have any questions about the setup, please leave them in the comments section.